So, welcome once again, everyone, to the today's session, which is the benchmarking of lithium-ion cells. I welcome you all again. Okay, so today's session will be about what exactly is the benchmarking and what are the different types of lithium-ion cells available there, and how could we get what exactly we require. So today we will be talking about that. And before moving ahead, I would like to let you guys know that you can interact in between, and I want this session to be very much interactive. Whatever doubts or discussion points you have, you can mention in between, or by the end of the session we can put those points and have discussion. And meanwhile, if I ask something, you are like, I expect you to be answering those questions, and to help me, like making perform certain calculations that we will do later on. Okay, so yeah, I hope you will respond in the session. Okay, so let's get started. So moving ahead, what exactly we will be learning in today's session, so that we will see. So the first thing, we will know what exactly the benchmarking is, and like what is the definition, some examples of that, those things we will have a look at. Then we will see why people perform the benchmarking, then what are different types of it, and then we will talk about the lithium ion batteries, how exactly, like what is it and how does it work. Then some characteristics of that. We'll perform various basic calculations on that, and after that we will see what is the conclusion. Okay, so let's begin with the definition. What exactly the benchmarking means? So benchmarking is defined as the process of measuring any product or service or process strategy against any of similar thing in other organization, which is considered to be as leader in multiple aspects. So that's what benchmarking is. So basically what happens when you have something of your own, or you are a owner of some product, or you are a developer of some product, and there are other people also in the competition, so you can measure your product, your service, or the your strategies that you follow with other person or the other company, other services which are available there. And you can compare it whether you are performing good or bad in this domain, or like it, okay. So those things are called as a benchmarking. Okay. So for example, let's say you have a, like you are a member of a formula team, and you have built your own car. So what you can do to make it more comparative, like more competitive, and to get the best out of it, what you can do, you can compare it with other formula cars which are there. So based on what specifications they are using, what, like if it's a e formula car, you can see what type of motor they are using, and battery size and the aerodynamic shape and all such things. So how exactly you can do this is by having access to the like their data, and if not, what you can do, you can have the some similar product at your end, and you can uh, tear it apart, and you can see exactly into it how exactly they have built something. So, like you have to dismantle each and every component of that car, and see by yourself what exactly the gear ratio they have been using, what kind of bearings they have used, and this how you can compare where exactly your product gone wrong, or the thing that you developed, how it, like why it is not giving that optimum performance. So that's how you can compare things. So basically, benchmarking is comparing your product or the your basically your product or service, whichever you are working in, with other competitors which are there in the market. So that's what it is. And you can also do at a student level as well, like self analysis kind of thing, that that student is performing better than me, so what exactly he goes, what strategy does it follow to understand the concept, what way he follows to solve the problem. So that also is a sort of benchmarking thing. Okay. And now we will see how the, like what reverse engineering is and how it is related to the benchmarking. So may I know, do you guys, like anyone of you understand what the reverse engineering exactly is?
We take the product as a reference,
Hmm.
start checking its performances, its design features, functions.
Hmm.
Then
Yes.
you start taking positive things from that and start working for the product.
Exactly, exactly. Yes, Jen. So that's the thing exactly. So what reverse engineering is, you already have something with yourself, and you haven't worked with that, but you want to develop very much similar product, or you want to like uh, develop something which is exactly the same. So that can be you can perform the reverse engineering, and reverse engineering is something replica of engineering. So in engineering, what steps you follow? You take one concept, you design, sorry, you get it sketched somewhere or put a sketch of it. Then you think about it, how exactly it will be. You perform certain calculations on that. Then you perform the CAD modeling. Then manufacturing process is done. Then testing is done, and then you get the final product. But what happens in reverse engineering? You already have the final product, and you want to get the blueprint of that, or the design specification of that. So what steps you do? So let's have some brainstorming on that, how reverse engineering could be performed. So let's say for example, I have given you just this very simple mechanical component, which is a bolt. So how will you perform the reverse engineering of it? I have given this bolt to you, and I asked you to give me its exact specification, or the exact dimensions, or develop the CAD model of it. So what do you think, in brief, what could be the steps?
Use my vernier caliper to
Hmm.
measure length and then use screw gauge to measure distance between two threads.
Hmm. Yes, great, great. It's Divanshu. Yeah, Divanshu. It's exactly right. So the what you will do, you will use the conventional measuring tools that you already have, and based on that, you will find out what exactly the parameters you can find. So in bold, there are no such specific parameters that you cannot find, except the thread angle, I suppose. So yeah, so that is the thing. Using vernier caliper, micrometers, and all these conventional measuring devices, you can calculate that, and you can draw it in some modeling tool like a CAD tool, AutoCAD, SolidWorks, or something. But if I say ask you to reverse engineering this product, how would you do that?
By taking a large number of photographs of this object and using reverse engineering tools
Hmm.
available online to generate model.
So basically, taking images from multiple aspects, and like from multiple angles, and doing. But there could be like various curvatures of different radii. So it could be very much complicated to get the exact dimensions which this product has. And like there
We
are
have to
lot
do
plenty of.
Tear down
Sorry.
process. Tear down process.
I couldn't get your point, Narendra.
Yeah, we can do tear down process, like
Okay.
disassembled, and we have to do.
Okay, fine. So what we can do in this scenario, like when there are very much complex
Well,
geometries.
this is obviously a part of something big, so we can
Hmm,
find out what.
hmm. So basically, it's a gearbox casing. You can assume. Okay. So moving ahead, how exactly it could be done is there is a term called 3D scanning, if you are aware of. So what happens, you use some digital devices which are called 3D scanners, as you can see here. And this is just very primitive type. There are multiple high-end scanners as well, to which gives a very exact like accuracy, and they would have a very wide range of scanning and all such things. So what happens, the product is reverse engineered, and the surface geometry is being created in a tool. So like here you can see the steps, as it's a very complex geometry. So what happens, you put it on a bench, and rotating bench basically sometimes. And I'm audible now?
Yes, sir.
Okay. So what you do is you put 3D scanner, and you rotate the table, and you capture the image from the different angles, and that's how you create the surface geometry of that. And if it does not go well in one go, you have to take multiple rounds of it until the you get the complete closed geometry, and you have to like mix the mesh, and convert it into the CAD model. So this scanner, it just gives you the surface geometry, basically, not exactly the solid model, because it doesn't understand it, how exactly it is made up of, and what part of it is solid. So we have to convert that surface geometry into the CAD model, and it happens manually as well. And in case of very critical geometries, there are certain conversion softwares. So like 3 geometry is one of them which I know. So you can convert those models into the CAD model, and based on that you can make modification as per required. So let's say you are designing some kind of wheel for your vehicle, and you want to make it a little different from what is there in some existing model. So let's say Hyundai Verna's wheel, you find it very fascinating. So what you do, you reverse engineer it, you perform the 3D scanning and prepare the CAD model, but you cannot have the exactly same model at your end, or you cannot put the very much same thing in your vehicle. You have to make modifications. So those modifications you can perform when you get the CAD model, and based on what modifications you have done, you can perform analysis whether these design modifications will it work or not in the real life situation. And based on that, once the analysis part is done and it's good to go, so you can make you can manufacture that product exactly. So this is the practice that most of the uh, industries do. Or like what happens, what this is something very much close to benchmarking, and this is what exactly happens in the benchmarking. Basically, what the people, they um, find out the exact product which is already there in the market. They analyze it and get it reverse engineer and manufacture with some modification. So that's how their research and development part is like. It does not take very much investment of time and financials. So this is what the reverse engineering is. And moving ahead, how what we can do after that is why exactly we need to perform the benchmarking, and what benefits will it give to us. So first thing is, it improves the effectiveness and efficiency. So if you are having certain process or like manufacturing process, and you got to know uh, this competitor of yours or the existing leader in the market uses this kind of strategy to prepare that product. So if you can relate or align your strategies with them, you will be able to get the very efficient results. So that would be a thing. And we will able to like understand what exactly other competitors are doing. Okay, so that will also be one reason. And you can also like you will be updated what exactly the other players in the market are doing, and how what is the your standpoint in the race. And lastly, you will know who is doing the best and how you can perform the best in that. So that would be a thing. Okay, so these are the some reasons for performing benchmarking. Now we'll see what different types of benchmarking are there. So there is a performance benchmarking, as we have already discussed, like how, so if your vehicle, let's say you have built some formula student vehicle and student level formula vehicle, so you can see what performance your vehicle is giving, and what other components. So let's say you went for Baha competition, and there you saw like the rankers who won the competition, they have built such an amazing performance vehicle. So you can see what is the difference in their performance and your performance. And along with that, there is a practice benchmarking. So practice is something like the strategy benchmarking, what strategy they have been following and what strategy you have been following, so that kind of thing. And there is an internal benchmarking. So internal benchmarking, which happens something internal in the organization, to compare, like if some business owner has multiple branches of it, so he will compare one branch with the other branch, why this is performing better and why this is not performing better. So this would be an internal benchmarking. And external benchmarking, you definitely would understand, comparing your organization, your industry, your product with some external party or external product. So these are the types of benchmarking. And now we will move forward to the another important topic of today's session, or maybe we can say a second part of it, which is lithium ion batteries. And I suppose you would be interested to learn more about this part. So what exactly lithium ion batteries are, you can see we have very vast application of batteries in our life. Like almost we are, whatever things, gadgets, devices we use, everything has a battery in it, and they are playing very important role here. So how exactly these lithium ion batteries work is yeah. So for before moving to that, may I know what all different form factors of batteries you people know, and if you can just mention few names in the chat box or unmute yourself so that we can have more interactions. Please,
There
man.
in the normal applications, it could be cylindrical,
Hmm.
square, rectangle, depending on the
Yeah. Yes, yes. So like there are cylindrical, as you can see, the cylindrical cells are there, then pouch cells are there, then prismatic cells, coin or button cells. So there are various shapes and factors. Lithium ion batteries are available in based on what exactly our requirement in what application we are using in. So based on that, we can select suitable geometry and suitable specification of lithium ion batteries. So just very quickly, we will see how exactly it works. So there are three major components. There is a cathode, anode, and the electrolyte. And between that, there is a separator. So what happens? At cathode end, the lithium ions are stored, and when battery is charged, they are forced to get like protons are forced to get to the anode side, and the electrons are forced to get via this channel, like the external circuit which is there. uh, Electrons are not allowed to pass through the electrolyte. So that's the property of electrolyte, it does not allow electrons to pass, it has to follow an external circuit path. And that's how the lithium ions, the lithium comes here, and they are in an unstable condition here. So what happens, they try to find out path to get out of here, and when they are connected to the external circuit, they protons, they immediately pass through the electrolyte to get stable, and electrons, they find the path through the external circuit, and that's how we get electricity. And both of them come here and combine here to get stability. So that's how the lithium ion cell basically works. We won't put much time on it because we have certain calculations to perform further. So now we will see what are the different parameters of batteries are there. So may I know, you guys have idea about like what are the things by which we specify the batteries or some properties of the batteries, so that after that you mentioned we can discuss on that.
Potential generator current.
Voltage per cell,
Yes.
voltage per cell,
Hmm.
and its geometry also.
Hmm.
Whether
Geometrical dimensions. Yes.
geometrical dimension.
Correct. There are other things as well, if you know. Yes, capacity, energy density. Exactly, Praveen. So let's have a look exactly what are the different parameters of battery are there. Okay. So firstly, there are the power and energy density. So like how much amount of energy or the charge does a battery store per volume or the per liter. So that's the thing we can consider as a energy density. So if do you guys know what exactly does the energy per unit volume or energy per unit uh, weight is called exactly? There are certain terms, if you guys know. Okay, cool. No worries. So what happens? Let's say you have a battery, okay, and how much energy it stores in like per volume. Okay, so I guess it's not getting very clear. So for per volume, how much energy it stores? So basically watt hour per liter. So this is called as a uh, volumetric. Okay, volumetric energy density.
Energy density.
Yeah, energy density or volumetric energy density basically. And for per kg of weight, how much energy it stores? So watt hour per kg. So it's called at galvanometric. Okay, galvanometric energy density. So these are the two terms which are considered when you select some batteries for your particular application. And next thing are the cost. Exactly, some chemistries are very much cost, like lithium ion titanate, lithium titanate battery. So they come like titanate is a noble metal, so it comes a little costly. So other chemistries which are like not that much costly, so that thing you can have a look on. Then commercial availability of that particular cell, those things needs to be considered. Then what temperature range they can be operated at, because batteries are very much sensitive to temperature. And from the safety perspective, it becomes very essential to know exactly what temperature ranges it will work in. If you are in a very like hot region and that battery cannot perform well in those high temperature regions, so definitely there could be a hazardous situation. So those studies you have to perform, like what are the available companies are there, and what all cell models they're providing, and what is the temperature range of that. So all these things you will find in a cell data sheet. Okay, so that thing you need to consider. Then comes the life cycle. So life cycle is like it's defined as number of cycles it can be charged and discharged. So that's the thing. uh, Batteries cannot be charged and discharged for infinite of time, based on what exactly, like for different chemistries it varies. So for lithium titanate, lithium titanate basically it's around 800 to 1000 life cycles. So that's how it differs for different types of batteries. And operation life is something where it gives the optimal performance, like it does not completely drain out all these things. Shelf life is what the like the component it is enclosed in, so all those things. And safety perspective is mostly does it catch the fire or it just release the smoke. those things have to be considered. And does it release some kind of toxic gases or such things? So those things has to be seen while going for selection of batteries. Then chemical compositions, as we have already discussed in the commercial availability of that. So there are different chemical compositions of the batteries. Okay, and there comes the electrical parameters of it. So there are typical voltages. So there could be nominal voltage, peak voltage. When battery is fully charged, it could give a very high voltage. For example, 4.2 volts maximum. But when battery is like not fully charged, it's at around 10% of state of charge, so it will have around 3.6 volts of charge. So and when it during in between these two stage, it is giving around 4 volts, so that would be a nominal voltage. And so there are three cutoff voltage, maximum peak voltage, or the nominal voltage. So these kind of characteristics are there. And charge discharge rate, so it's basically a C rate. Okay, C rate means in 1 hour of time, how much current it can provide. So how much time it would require to completely empty the battery pack. So that's how C rates are defined. And C rate plays very important role when you talk about fast or slow charging. So and yeah, when C rate, if you take very high C rate, you will surely get fast charging. But having high C rates increases the temperature of the battery drastically, and that affects the overall life of battery pack. So those things are there. And overcharging and discharging protections. So like when battery gets overcharged, how much temperature rise will be there? Will there be a swelling? So specifically, what happens in case of pouch cells, there happens swelling. And you might have seen the mobile batteries, they get swiveled or they get thickened when they are almost died. So that thing happens. So that those things needs to be considered. And what are the cooling techniques you would require? Whether the temperature it's going, will it gonna affect the long life of battery pack? So based on that, you have to decide the cooling techniques for the battery. So these many parameters you have to look when you go for selection of batteries. Okay. Now we will move ahead with what are the cell specifications available with the different manufacturers of cells. So there are multiple cell manufacturers in market, and as this industry is booming, so for specifically for electric vehicle application, here are few of the companies and their what type of cell they have been manufacturing, what the model name is, and the specification of that is given. Okay, and with these specifications, what we will try to do, we will try to find out some parameters that we are looking for. So those parameters, what they would be, so energy density, basically volumetric energy density, and galvanometric density. So these kind of things we will try to find out by performing certain calculations. So now I will present my screen. Oh, just give me a minute.
Has anybody started in India indigenized manufacturing of lithium-ion batteries for electric vehicles?
Yeah, there are like not the big players, but some startups are there who have been setting up their own lithium-ion battery manufacturing plants.
Can you
The
just
Tata is trying to involve.
Tata, they have been getting it from suppliers. So there are like no such updates from Tata whether they have been manufacturing or not. But I have seen like there are some startups as well who have been setting up their plans. So yeah, those are the things.
Bhagat, can you just glance that last slide? What parameters?
Okay, yeah, I'm sorry. Is my screen visible?
Yes.
Yeah. So yeah, someone was asking.
No, after this, before we move to the calculation, he was showing one, explaining one.
Yes. Mm-hmm. Okay, after that. Yeah, this one.
Yeah. So this is a base for our next calculation.
Yeah, we can say that. Yeah. So these some of these parameters we will be using to find out some outcomes of that. Okay. Okay. So moving ahead, I was sharing the Excel sheet basically. Is my screen visible?
You have to make a full screen.
So actually, if I have to shift to the presentation part sometime, so that's why I cannot put the specific tab itself. Okay.
Okay, it's
Is there?
okay.
Yes. Okay, fine. So what parameters we have is from Panasonic, the cylindrical cell model that they have. Its length is given, and diameter is given, and mass, the ampere hour capacity, then voltage, continuous C rate, and the peak C rate. So these things we get from the Panasonic cell sheet, and based on that we will try to find out which has the like a good volumetric energy density and the gravimetric density basically. Okay. So energy, how in terms of electricity, how exactly we find out the energy is power basically. So power, just let me. So power is equal to V into I. So V is the nominal voltage that one cell has, and I is the current rating that it gives. Basically, the current output that it has. So that's how we get the power of the battery pack. So how we are gonna do it is we have the nominal voltage and the ampere hour rating of it. So we will multiply both of them. That's how we will get the watt hour capacity of the battery pack. Okay. So we just have to put equal to here, and the voltage, which is a nominal voltage, into the ampere hour capacity, and that's how it will give us the uh, energy of that particular cell. And after that, for this as well, we can perform the same thing. If we just drag it here, it will calculate the same thing for the A123 system cell as well. And for volume, we have to divide this energy with the per liter volume of the cell. So how we will do it? Equal to sign the energy divided by the volume. So firstly, we will have a volume cell here, is somewhere here. We calculate the volume. Okay. And yeah, as these are the cylindrical cells, so how we will calculate the volume of that? Yeah, can you guys mention the formula of volumetric cell? Sorry, the volume basically of
Pi
the
d squared.
cylinder.
Pi d squared by into L.
IR square H.
Yeah, so I R square H yeah, so pi by 4 d square into h is the same thing. So as we have diameter, so we will use the diameter formula, 3.14 divided by 4 into the diameter square. Diameter into height. So length we have been given, and it will give the volume in meter cube. And to convert this meter cube volume into liters, what we will do, we will multiply it by 1000, that we get the volume in liters. So this is the volume of one cell in liters. And
These
same
are
thing.
all very, it is not possible to imagine the size and all by human eyes or brain.
Mhm.
It is
Yes.
0.017, I don't know.
Okay. So now, as we have found out the volume, we will find out the volumetric energy density. And how exactly it is. It's just the ratio. We have to divide the total energy of a cell with the total volume of one cell. So that's how we will get the energy density per liter. And if we just drag it here, we will also get the value for the A123 system. And similar way, we can find out the gravimetric energy density and what exactly it will be. So just the division of energy by the mass of that particular cell. It will give the uh, gravimetric energy density. And now we can see like which cell would give the better higher energy density. So in terms of volume, if we use Panasonic cell, it will give me a more high density, like almost double of the A123 system cell. And in terms of gravimetric energy density also, it's about more than double of that. So that's how you can analyze different cells available in the market for the various parameters. And if I go to
Who is the
presentation,
A123 is a manufacturer?
yeah. A123 system is a cell manufacturer. So like
Again, a
Toshiba,
Japanese
uh,
company.
the origin of that I exactly don't know. But yeah, the A123 is a manufacturer, battery manufacturer basically. And now we will just jump to some complex problem. Here we just analyzed how exactly we can differentiate with the uh, different densities, energy density. Now we will have a look at if we are given certain ranges, and based on that we have to find out some variables. So those things we will have a look at. Okay. So here are the assumption which is given. Like we have to design a battery pack for 250 kilometer of range of certain vehicle, and the cylindrical cells we have to use, and length of each cell, diameter is given, mass is given, cell capacity, ampere hour capacity is given, voltage, no continuous C rate and peak C rate, and along with that, what is the watt hour per kilometer consumption average value, that is also given, and what is the nominal battery pack voltage. So these are the things we have been provided, and based on that we have to find out these much parameters. And what are these parameters? Like we already found the cell energy, cell volume, then basically the energy densities we have to find out. Then we will see the number of cells in string. So a string is the cells connected in series. So that is called a string. So how many cells we have to connect in series, how many cells we have to connect in parallel, those things we will see. And after that, we will find out what are the total number of cells we would require to have a battery pack, which will give us 250 kilometer of range. And what will be the peak current of that? What will be the peak power of that? So these parameters we will try to find quickly. Okay. So I suppose you would help me find out these parameters, and we will solve it by mutual discussion. So firstly, let's understand some basics of when cells are connected in series, what happens, and when cells are connected in parallel, what happens. So when cells are connected in parallel in this configuration, parallel configuration, so if these cells are there and we have connected them not by end to end in a parallel manner. So all the positives are connected together, all the negatives are connected together, and that's how we will be get what output we will be getting here. So let's say V is a voltage of one battery pack and I is a current rating of one battery pack. So what would be the output here? V output and I output. What will be those values? Anybody could give some idea how exactly it could go? Okay. So what happens when you connect cells in parallel connection? The voltage, it remains constant. Okay, it remains constant at each cell is connected like at same potential. So the V output will be the same itself. What happens? The current gets added. Okay, so the current is getting out of this particular cell, then here it's getting added here, then this one is also getting added. So that's how we get the current added in a parallel configuration, and that's how we get 4I as the output current. Okay, and this configuration is a series configuration. So how exactly it is? The positive end of one cell is connected to the negative end of the another cell, and same thing goes, and this is how it forms the string. So this is a series connection and also called as a string of cells. So what will be the output voltage and what will be the output current? I0. Okay, can you guys answer those things?
Voltage will be added.
Mm-hmm.
Current will remain same.
Exactly. So what happens? Current is having a same path to flow. So current will remain same as I, but as cells are attached end to end, the voltage of the cells will, overall connection will increase. So it will give 4 volts as the output voltage. So that's how the series and parallel configurations we achieve various output parameters. Okay. So now we will come to our calculation part, how we are going to do that. So firstly, let's find the cell energy. So cell energy, we have already done that in our previous calculation. It's just a I will zoom in more so that you guys will be able to see it clearly. Okay. Yes. So it's just a multiplication of voltage, nominal voltage, and the current capacity. And that's how we get the that are energy. Then cell volume. So cell volume is, we already have done that calculation. It's nothing but pi by 4 into the diameter square into the height of the cell. So and this is in a meter cube, so we want multiply it by 1000. Then energy density of so gravimetric density basically. So it's nothing but, as you guys already have learned, one cell energy divided by the weight of mass of the one cell. So that's just simple thing. And now for volumetric, we just have to divide it by the total volume that we have calculated. Okay, but it is asked in the liters. So what we have to do, we have to convert this volume into liters. So what we will do it here. We will take this and multiply it by 1000, and in this formula we'll just make this C2. We will take this value. So now we have got the energy density. So it will be 1000 watt hour per liter. Then average energy consumption, it has already been given in the value. It's 165.12. So let me show some lights on that. What exactly the watt hour per kilometer consumption is. So you know the mileage of the vehicle. How, what is the unit of finding out the mileage in conventional petrol vehicle basically?
Kilometer per liter.
Yes, so kilometer per liter. And if we just
kilometer per gallon.
oh yes, kilometer per gallon. It's followed in US.
America.
So so you find out how much kilometer it will go in 1 liter of fuel. So in if we find out the mileage of electric vehicle, how we can calculate is kilometers run per unit battery capacity. So which will be a watt hour. And if you just make a reciprocal of it, which will be a watt hour per kilometer, so it will give you how much watt hours are required, or how much watt hour of capacity does the vehicle consumes for running 1 kilometer of distance. So that is the watt hour per kilometer value. Or we can say how much fuel does it require to go 1 kilometer of distance. So that's the thing, and this is the average value of a vehicle which is given. And based on that, what how we can find the total battery pack capacity. This total battery pack capacity, firstly we will find out. Okay, so
Is the quality of a battery is defined like this? Kilometers per
no,
watt hour?
it's the kilometer per hour is, sorry, kilowatt per hour is a property of a vehicle. It's a specification. It comes under the specification of vehicle, not the battery exactly. So it varies in different conditions. If the weight of the vehicle is high, or like if you are not running in a very efficient condition, so this value would go high.
Correct. Yes.
Yes. So it's a property of vehicle, not the battery. Now, why how to find out the watt hour, how exactly the energy we require in battery pack? So it's very simple. We just have to multiply the total range that we have, that we will be running our vehicle at, with the total average consumption that vehicle will have. So if we just multiply by these two things, we will get how much battery we will be requiring, how much capacity of battery we will require. So this thing multiply by the total range. So this much of watt hour of battery we would require, and if you just divide it by 1000, we will get it the kilowatt hour capacity of the battery. Okay, and from this we can calculate other parameters as well. So as we already discussed in a previous slide, that the total power is what voltage into the current. And now like if we take current in ampere hour, it will give us the energy, and if we just take it in ampere, it will give us the power. So now what we already have is total voltage of the battery pack, which it has already given here. So it's 400 volts, right? And we have the total energy of the energy capacity of the battery pack. So this how we have two things here, and we can find out the current. So how the current it will be? It will be total energy divided by the voltage rating of the battery. So that's the simple thing. Okay, so battery pack ampere hour capacity, it's the total energy divided by the voltage rating, or the nominal voltage of the whole battery pack. And this is how we get 103 ampere hour as a nominal uh, and how exactly we will find out the number of cells in one string? So as we have already seen, string is called series connection, right? When cells are connected in series, we call it as a string. And how we will calculate how many cells we would require in string? So before that, we have to find out number of strings basically. I'm sorry. So firstly, we will see what would be the one, how many strings you would require. So we already have the total voltage 400 volts, and we know the voltage of each cell. So we will know exactly how many number of cells in parallel we will have. Okay, so number of strings is just the multiplication of, sorry, division of total battery pack voltage divided by the one cell voltage. So that's how we will get the number of strings. Okay, and in one number of string, how many cells has to be there? So that thing how we can calculate is just we already have 121 cells in one string, which will, what happens, the voltage gets multiplied. So that's why we have divided by voltage. And to find out, now we will connect those strings into the parallel configuration, and which will add on the total current. So what we will do, we will divide one cell current with the total current capacity of the battery. Okay. So number of strings in one cell is equal to total ampere hour capacity divided by one ampere hour capacity of one cell. So that's how we will have 42. And string energy is nothing but total energy into number of cells in string. So this is the total energy of one cell into the total number of cells in string. Okay. And how we will what will be the total number of cells? It will just be multiplication of this number of cells in string into number of strings. So it will give these value. Okay. And rest of the things are like the mass of the battery pack. We have to just multiply one cell mass with the total number of cells. Then total volume of battery pack will be multiplying one cell volume with the total number of cells. And similar way, you can try to find out the other parameters as well. Okay. So these kind of calculations or the study you have to perform when you are selecting any kind of cell for any particular application or the battery pack that you are designing. So you have to perform similar calculations for various types of cells available in the market, and that's how you have to do the benchmark study basically. So you can see what all different players in the market who are manufacturing the cells. What different, like there are pouch cells as well, prismatic cells as well. So how their energy density will differ, which will give the best energy density, and the C rates, which cell gives the higher C rate value, so that you can charge your batteries in a faster way and get the peak outcomes when the performance is required. So these kind of studies you have to perform with the various available models in the industry. So that's how it goes in the selection of batteries and the benchmarking in the study. Okay. And now we will have a short review of what we have learned, as it's already 5 o'clock. So we saw what exactly the benchmarking is. Then we saw how reverse engineering is done. Like I showed you example of bolt and very complex gearbox casing. So how exactly reverse engineering runs? You understood with the help of 3D scanners. You have to scan each and every part of it, then convert it into CAD model, then perform certain changes if required, perform analysis, and you can go for some kind of manufacturing process, 3D printing or conventional processes. Then why these studies are done? What are the what exactly key benefits of that, those things we saw, and different types of benchmarking like internal benchmarking, external benchmarking, process strategy, all those things we learned. And we saw understood the working of lithium ion batteries, their characteristics, and we performed various calculations as well to find out some like we had been given certain range and consumption values and cell specification. Based on that, we found out how many cells we would require in series, parallel, and what will be the ampere hour rating of the battery. So those calculations we have learned. So yeah, so these are the things we have covered into this session. If you have any questions or some point of discussion, you can mention.
Very nice way of explaining.
Thank you, thank you.
We may have to learn many things. Of course, we are. These are all very, very essential for the new people who want to get into this, electric vehicle thing. The only thing I want to ask, what is the manufacturing process involved in connecting all these cells in series, parallel? Is it these are all in a nanoparticle size? Is it not?
So the manufacturing of lithium ion cell is very complex, and that's why not there are not very much industries. The people who have been doing this for long year only they have been performing it till yet. But as the industry demand is increasing, people are the more industries are coming into the domain. So yes.
Okay, but some of these things, one is mostly batteries will be vehicle manufacturers may ask this.
Mm.